Good day, everyone. My name is James, and welcome for the last topic for provings, proofs. So we have the principle of mathematical induction, or we should also say mathematical induction, or we should say proof by induction. So it is a mathematical tool used to prove a mathematical statement, an effective way to help you identify and correct flawed mathematical statements. Also, it is also a mathematical tool. The other definition of mathematical induction is a mathematical tool in establishing the proof of a given mathematical statement or conjecture involving all positive integers from some point forward. So in this session, we're going to have only positive integers. Considered lang na positive integers lahat. And also sa principle of mathematical induction, that we have to prove this statement to the left hand statement to the right hand statement. So you're going to prove the left hand statement, and to prove the left hand statement to the right hand statement, dapat ano sila, they're equal, baga, no? So the left statement is also um, uh, equal to the right hand statement. So in this one, no, yeah. So let P of n be a statement that involves the positive integers n if we have the initial case, okay, where P of 1 is true, okay, that's our initial case, where n is equal to 1. Okay, now we have the inductive hypothesis, okay, because we assume that the statement is true for n is equal to k. And we have the induction step. Wait, okay, we have the induction step to prove that the statement is also true for n is equal to k plus 1. And we have the conclusion. To conclude the statement that is proven for now. So these are the four steps that we have to follow in accordance of the principle of mathematical induction. So, okay, so let's have it. Okay, for the first example, okay, we have the even integers. So these are even integers equal to n times n plus 1. So we have to prove that this statement is equal to this statement. So in here, okay, C2, oops, C2 hanggang kay 2n, that is our P of n. Okay? It's P of n ito. Si left hand side. Okay? So, yan si P of n. Now, we have to prove that P of n is equal to this one. So, we must use mathematical induction. So, we have these steps. Okay? The four primary steps in solving or to solve or to prove the uh, statements using induction. So first things first is we have the initial case first. So we have the initial case. Okay. So when we say initial case, we let n equal to 1. So n is equal to 1, probably that was the first term. Okay. So that probably the first term. So to establish this, we have to get the first term and this. That the first term and this term are equal. So our first term is 2 equal to n times n plus 1. And there are two cases to prove. You can use 2 or you can use 2n. 2n is equal to n times n plus 1. So you can use that. So there are two cases in that thing. So how we're going to prove? So let n equal to 1. So we have 2 equals 1 times 1 plus 1. So we have 2 is equal to 1 times 2. Therefore, we have 2 equal to 2. So we have that. And the other case is for 2n, where n times n plus 1. So we have 2n is equal to n times n plus 1. So how we're going to do that? So let n equal to 1. So we have 2 times 1 is equal to 1 times 1 plus 1. So we have 2 is equal to 1 times 2. Therefore, we prove that 2 is equal to 2. So our P of n, or P of 1, is proved. So that was the initial case. Check. Okay, P of 1 is proved. Now, after that, we're going to substitute. We're going to have the next step, which is probably the inductive hypothesis. Okay, anong meron kay inductive hypothesis? We're going to assume where n is equal to k, probably true. Okay, we assume that n is equal to k, a k be true. So for the inductive hypothesis, okay, inductive hypothesis. Yan. So we're going to get that, we're going to assume pala na n is equal to k is true, no? Or p of k is true. Okay, so how we're going to do that? So we first write the statement first. So 2 plus 4 plus 6 plus 8 plus ellipsis plus 2n times n plus 1. Then after that, we're going to let n equal to k. Okay, so we have 2 plus 4 plus 6 plus 8 plus ellipsis plus 2k equals to k times k plus 1. So automatically, that if we're going to solve, no, using the induction step, okay, you have to do that. We have to use this inductive hypothesis para na if we're going to solve for the, or we're going to prove that statement, we use this statement, no, inductive hypothesis, no, in getting to prove with pag meron na tayo sa um, induction step. Kumbaga. So that was the inductive step, inductive hypothesis. Now, for the induction step is we're going to have um, to rewrite all. No? So we have the inductive hypothesis. So let this be assumed be true. Now let P of k be true. Assumed to be true pala. So the assumption, no? The assumption of the hypothesis. Now for the induction step, so how we're going to get the induction step? Okay, we must first rewrite this. So pwede, hindi na niyo isulat. So pwede yan. It's your choice. It's your liberty. Kumbaga. N times n plus 1. So in this time, we're going to need, okay, to have the inductive hypothesis. So insert natin si inductive hypothesis dito. So let n equal to k. So magiging 2 plus 4 plus 6 plus 8 plus blah 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 plus 2k is equal to k times k plus 1. Now, okay, that is for the inductive hypothesis. Now, where do we insert the induction step which will be proved that n is equal to k plus 1? So as you can see, we have 2k here. Pag i-add natin ng isa, k plus 1, that would be the ahead of 2k. But in the right hand here, we're going to substitute k plus 1. So, magiging k is equal to k plus 1 na siya. Okay? So, how we're going to do that? So, ganito. Okay, we must first write the hypothesis with adding k plus 1. So, 2 plus 4 plus 6 plus 8 plus blah 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 plus 2k. Then we're going to add na naman 2 times k plus 1. Why is it 2 times k plus 1? It's because from the to n, okay, equals to k plus 1 times k plus 1 plus 1. Okay, so yan. Yung n natin is k plus 1, n natin is k plus 1, add na siya kay 1. So ganyan. Okay, then after, you're going to simplify this. So this would be your inductive hypothesis. So we have 2 plus 4 plus 6 plus 8 plus ellipsis plus 2k plus, okay, di na natin to i-distribute ha. So we're going to have to factor na lang para mas madali. So times k plus 1, ito yung ating i-simplify. So times k plus 2. So this would be your induction step. So this could be used to prove that this right-hand limit, right-hand limit, right-hand hypothesis, right-hand statement equal to the left-hand statement. So how we're going to do that? So after that, we're going to rewrite the induction step. So 2 plus 4 plus 6 plus 8 plus blah 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 plus 2k plus 2 times k plus 1 equal to k plus 1 multiplied by k plus 2. So ito na. How we're going to solve that? Okay, remember that I say that this 2 hanggang kay 2k, we let this statement be equal to k times k plus 1. Okay, so k times k plus 1 plus, then after that we have 2 times k plus 1 equal to k plus 1 times k plus 2. Now, bakit natin or why do we replace this statement into k times k plus 1? So, in ruling the induction, we must replace that because we can't prove the statement if we cannot replace this one into a simpler one. Okay? Kasi equal naman sila, di ba? We're going to assume that this statement is equal to this statement. So, in forming the induction or in forming to prove that statement using induction, we must or it is necessary to replace this statement into a simpler one para in getting to solve deeply with the use of induction. So uh, uh, yes, we're going to solving deeply in induction. We find out that that statement is true to all even numbers. So how we're going to do that? Okay, so we're going to continue this. So we must factor out the common factor of these two, para ma-equal siya dito. Kasi dito sa right-hand statement, that would be fixed na siya. So fixed value na siya. Ang kailangan nating i-prove is this statement to form this hypothesis or this statement. So, okay, so of k times k plus 1 plus 2 times k plus 1, the common factor of the two is k plus 1. So we must factor out k plus 1, okay, k plus 1 times k plus 2 equal to k plus 1 times k plus 2. So where's it? Prove. Okay? Equal na silang dalawa. So, by the fourth one, we have the conclusion. Okay? So, we get the conclusion. So our conclusion is, therefore, the statement 2 plus 4 plus blah 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 plus 2n equal to n times n plus 1 is true for all positive even integers. So, ganyan ang ating, or this would be your conclusion. So, ganito ang uh, pag-conclude ng statement. So, therefore, the statement 2 plus 4 plus 6 plus 8 plus 2n is equal to n times n plus 1 is true for all positive even, or pwede, it's true for all values of, or pwede na yung positive even, or for all even integers n. Tama pala. Wait. Even integers n. So, kasi may n man. So, ganyan yung conclusion niya. Okay? So, what is the next one? Okay. So, that is our conclusion. Now, okay. For the next step, or for the next statement is this. So, let P of n be 1 plus 3 plus 5 plus 7 times plus ellipsis plus blah 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 plus 2 times n minus 1 is equal to n squared for n is less than, greater than or equal to 1. So by nature, or by natural numbers, we are going to deal with it. So ito yon. P of n, tsaka ang ating ipoprove is going to equal by n squared for all. Ito yung interval niya. N is less than, greater than or equal to 1. So how are we going to do that? So first things first, you have to solve first for the induction initial case pala, initial case. So for the initial case, there are two ways. But let P of n, P of 1, where n is equal to 1. So our initial case is to prove that the first term is equal to the result. So there are two cases. It could be 2n minus 1 equal to n squared, or 1 is equal to n squared. But to figure out easily, so we're going to use the first term 1. So we have 1 equal to n squared, then let n be number 1. So 1 is equal to 1. So therefore, we prove that P of 1 is true. Okay, so P of 1 is true. So therefore, after the P of 1, we have the assumption that n is equal to k. We have the inductive hypothesis. So, ganyan lang ka-easy. Okay, inductive hypothesis, they assume P of k is true. So this, our assumption here is we're going to assume that P of k is true. So, diretso na tayo para mas. So, let n equal to k. So therefore, we have 1 plus 3 plus 5 plus 7 plus the ellipsis plus 2k minus 1 equal to k squared. So, yan. So this would be your inductive hypothesis. So our inductive hypothesis is ganito. So, where, tawag ito, um, for all um, positive integers, Tama ba? For all odd integers. Kasi odd integers lahat. No? For all values of odd integers. So, yan. So, next step is we're going to have the induction step. So, our induction step is very easy. No? So, we let this 1 hanggang kay 2k minus 1 be equal to k squared. So, how we're going to do the induction step. So, for the induction step, we have 1 plus 3 plus 5 plus 7 plus ellipsis plus 2n minus 1. Ano lang? 2 times k minus 1 at k plus 1 minus 1. Ano? Wala. You have 2k first, then add naman by ano, 2k minus 1 plus 2 times k plus 1 minus 1 equal to k plus 1 squared. So, ganyan. Okay. Um, okay, so how we're going to do this? Now, since we have added k plus 1 to the loop group, so we're going to let 1 hanggang kay k minus 1 equal to k squared. So we're going to have, okay, so we have k squared plus 2 times k plus 2 minus 1 equal to k plus 1 squared. Then we have 8k squared plus 2k plus 1 equal to k plus 1 squared. And the factor of k squared plus 2k plus 1 could be k plus 1 times k plus 1 is equal to k plus 1 squared. Then we have, tapos same man sila, so we have k plus 1 squared is equal to k plus 1 squared. And it proves that, okay, conclusion na tayo. Then our conclusion that therefore, okay, pwede din thus, the statement P of n or the statement 1 plus 3 plus 5 plus 7 plus blah 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 plus 2k minus 1 is equal to n squared. Ano na? 2n minus 1 equal to n squared is, oops, wait. N squared is true for all values of n is greater than or equal to. Yeah, so that would be our conclusion. Okay, so very stressed, diba? Very stressful. But yeah, let's go have the assumption after. We have last example. So our last example is all about hmm, okay, that's our conclusion. Put it thus or therefore the statement is true for all values of n is greater than or equal to 1. Now, for the last example, we have the square of the number equal to n times n plus 1 times 2n plus 1 all over 6. So how we're going or how we're supposed to, to do to prove the statement P of n to the result of the conjecture or the hypothesis. So we must we must use first or we must have first the initial statement. So for the initial statement is we're going to prove P of 1 is true. So importante talaga na may initial case. So initial case where P of 1 is true. So our P of 1, so we have P of 1, okay? For the first statement, we have 1 squared equal to uh, n times n plus 1 times 2n plus 1 divided by all over 6. So you have 1 squared is 1 is equal to n is our 1 times 1 plus 1 times 2 times 1 plus 1. So we have 1 all over 6. So we have 1 is equal to 1 times 2 plus 1 all over 6. Then we have 1 is equal to 2 times 3 all over 6. Then we have 1 is equal to 6 all over 6. Therefore, we have 1 equal to 1. So this proves that 1 is equal to 1. So therefore, P of 1 is true. Okay? For n is equal to 1. Now, how about the inductive hypothesis? Okay, for the inductive hypothesis, we let n equal to k. And we're going to assume that P of k is true. Okay, dito na lang. If, if, if makaya. So our inductive hypothesis, no, we let n be equal to k. So we have 1 squared plus 2 squared plus 3 squared plus 4 squared plus blah 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 plus k squared equal to k times k plus 1 times 2k with k plus 1 times 2k plus 1 all over 6. So this would be your inductive hypothesis. So that would be your inductive hypothesis. Now, we have the inductive hypothesis. We can now uh, use this for the induction step. So our induction step dito is we're going to prove that k plus 1 is also true. Okay, so how we're going to do that with for a while lang. Okay, so we're going to prove that k plus 1 is also true. So p of k plus 1 is also true. True. So how we're going to do that? Okay, by the induction step, we have p. Okay, first we're going to write first the inductive hypothesis added by k plus 1. So we have 1 squared plus 2 squared plus 3 squared plus 4 squared plus blah 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 plus 2k, ano, k squared pala. K squared plus k plus 1 squared plus k plus 1 squared. Okay. Then equal to, we have plus k plus 1 times k plus 1 plus 1 times 2k plus 1, okay, 2 times k plus 1 plus 1 all over 6. So that would be, yes, that would be our, okay, first step to prove. Then we're going to let this one equal to our the assumption of our hypothesis. So we let this equal to k times k plus 1 times k plus 2k plus 1 all over 6. added by k plus 1 squared equal to k plus 1 times k plus 2 times 2k plus 2 plus 1 all over 6. Okay, bakit 2k plus 2? So 2 times k, then 2 times 1, then added by 1 na naman. So after that, okay, ito simpler form. Ito, ano na to. So to prove that, we're going to get the LCD. So we have 1 over here, automatic 1 dito. So our LCD here is 6. So 6 divided by 6 is 1. 1 times k plus 1 times 2k plus 1 is k times k plus 1 times 2k plus 1 plus 6 divided by 1. So we have 6 times k plus 1 squared is k plus 1 squared. 6 times k plus 1 squared. So 6 times k plus 1 squared. Then after that, we have this. Simplify na to fix the value. So we have k plus 1 times k plus 2 times 2k plus 3 all over 6. Then after that, okay, equal ng denominator. After that, we're going to simplify it here. But first, we're going to factor out first the common factor. So our common factor here is k plus 1. So we have k plus 1, labas si k plus 1 times ang nasa uh, loob lang is k times 2k plus 1 plus 6 times k plus 1 all over 6 equal to k plus 1 times k plus 2 times 2k plus 3 all over 6. Okay, then after that, we're going to simplify this. So from k plus 1 times the quantity of k times 2k plus 1 plus 6 times k plus 1, we're going to simplify the inside. So simplify natin to. So we have k plus 1 times uh, 2k squared plus k plus 6k plus 6 all over 6. We're not going to multiply k plus 1 to 2k squared plus k plus 6k plus 6. Okay? In order to do that, we're going to simplify this then to factor out na naman. Para maging k plus 1 times k plus 2 times 2k plus siya all over 6. Then we are going to simplify, so we have k plus 1 times 2k squared plus 7k plus 6 all over 6 equal to k plus 1 times k plus 2 times 2k plus 3 all over 6. So now we have 2k squared plus 7k plus 6 and it can be factored out. Okay, it can be factored out. So how are we going to do that? We're going to find the probably the most um, frequent. We're going to find the factors of this one. Okay, we're going to multiply this 2 and 6. No. Yes, we're going to find this one. So how we're going to do? So let 2 and 1 be the factors of 2 and 6 be 6 and 1 and 3 and 2. So that would be the factor of 6. So how we're going to do this? So we add, so we have 2 times 6, we have 12. And 1 times 1, 2 times 1, so ganito siya. We have 2x plus 1 times x plus 6. Okay? And 2x plus 1 times 3x plus 2. Okay, no na lang. Ito na. Para mas madali. Okay, we're going to use um, okay, okay. So ako na lang para mas madali. Okay. So to factor this, um, yeah. So the factor of 2k squared plus 7k plus 6 will be k plus 2 and 2k plus 3. Okay, let us have this one. Okay, k plus 2 if satisfy ba siya sa condition. So we have 2k squared plus 3k plus 4k plus 6. So we have 2k squared plus 7k plus 6. So this would be your factor, the factor of this quadratic one. So we have k plus 1 times k plus 2 times 2k plus all over 6 equals to k plus 1 times k plus 2 times 2k plus 3 all over 6. So our conclusion, to conclude, okay, we have therefore the statement 1 squared plus 2 squared plus 3 squared plus 4 squared plus blah 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 plus n squared is equal to n times n plus 1 times 2n minus 1 2n plus 1, okay, all over 6 is true for all values of n. So, ito na siya. And we're done. So, yeah, that would be our conclusion. So, therefore, we are done on the mathematical induction, and I will see you next time. That's all, and